Hello everyone. I want to continue our discussion of factoring. In the first video, we factored the greatest common factor out of an expression, so that if we had an expression that looked like that, we wanted to see what did it look like prior to being distributed. So we wanted to produce that parentheses, which we know is multiplication. So we asked ourselves what number came out of 3 and 12 at the same time. The answer was 3. We also asked ourselves, between x and x to the second, what's the most x's that I can pull out? And we said we could pull 1 out. So if we pulled 3x out of the first term, we said there would be no leftovers. However, I can't put a 0 there because I'm going to multiply and I'm going to distribute. So if I distributed 3x times 0, that would give me 0. Right? So we're asking ourselves, what number do I really get when I have 3x over itself? 3x. So 3 over 3 is 1, and x over x is 1, so that's a 1. And we bring that plus sign straight down, and we ask ourselves, if I pulled a 3 and an x out, what would be left inside the parenthesis? 4x. And so there is the expression factored. 1 plus 4x is the leftover section, and the GCF, the greatest common factor, is right out there up front. Okay, so we said that the process of factoring is creating multiplication. So today we want to talk about factoring quadratics, which was the entire chapter 5 unit, quadratics. And we remember that the quadratic standard form is something x squared plus bx plus c. And it's a 3-termed expression, 1, 2, 3 terms, trinomial. And in this particular example, and on this page, we're going to make sure that the a is equal to 1. So the a will always be equal to 1, and it'll be our first type of factoring. Now, let's look at it backwards. So let's look at what it would be multiplied as if we're going to have 2 terms, 1 x plus 4 times x plus 4. Okay. And we're going to multiply those together. You can see that Professor Cockerham already set up and said, hey, most of you guys remember that as FOIL, first, outside, inside, last. I would rather say that it's a double distributive property where the first term x gets pushed into the other first term, giving us x squared, and then that first term gets distributed into 3, which gives us 3x. We got a plus sign in between. And then we distribute. We're done distributing that first term, so now we distribute the 4 gets into the first term, 4x, and 4 times 3 is 12. You see it there? Probably much prettier than me messing with it, right? So let's see if I can clean up this part right over there, that 4x piece. Okay, so come on, erase for me. All right. So you see that 3x and 4x got a double slash mark because those come together. So our first term, x squared, is in the final result, and 3x and 4x is 7x, and the back number is 12. Okay. So you're going to say, where are we going with this? Well, let's give it a couple minutes, and I think you'll see where we're going. So I would like you to distribute these 2 terms together, x plus 2, a binomial, multiplied by another binomial, 2 terms times 2 terms. 2 times 2 is 4. Look at what we get. So when we multiply the first 2 together, we get x squared. We multiply that 6 and x, we get 6x. Then we take the 2 and we take the sign in front of it, positive 2 times x. It's positive 2x, and 2 times 6 is 12. Once again, those two terms are underlined, and we get x squared plus 8x plus 12. Okay? And so I would like you to try this one. Take a second if you can, and pause the video, see what you get. Hopefully you spent a second and paused it, and we set up the distributive property again, and that gives us, let's use blue, and that gives us x squared, and then we distribute and we get, watching those signs now, we have a minus and a 4x, and now we'll distribute the negative 5, hook that negative along with it into the x is negative 5x, and negative times negative is positive. 5 times 4 is 20, and once again we get an answer of x squared. Once again, those centers combine together, minus 9x plus 20. So I'm going to put it over here, and whoops, minus 9x plus 20. And if you look at your worksheet, do you notice that the 9 is the sum, way back over here, watch my arrow, of the negative 4 and the negative 5. When they add up, they give you negative 9. And when you multiply that negative 4 times negative 5, the product or the multiplication of those two, look, it works for all of them. If I come to, I'll use yellow. If I have 2 and 6 in the previous problem that I'm circling there with yellow, those numbers add to be positive 8 and multiply to be positive 12. Okay? So if we see a pattern here that this middle number happens to be, again, one last time on that first problem, 4 and 3 added together making 7 and multiplied together giving us 12, we see that if I gave those problems to you backwards, we should be able to figure out what the factors were. So look at the first problem. I'm going to ask you to factor. So now I have it all expanded out, and I want you to tell me, what did it look like with the original 2 parentheses? Okay. So remember, the back number is multiplication. So it's got to multiply to be 30, and it's got to add to be 11. So can you think of 2 numbers that multiply to be 30 and add to be 11? First of all, think of the numbers that multiply to be 30. That should be your first move. And you should be listing them. 1 times 30, 2 times 15, 3 times 10, and 5 times 6. Which combinations of these numbers, okay, will add to be 11? There it is right there. 5 and 6 multiply to be 30, right? They multiply to be 30, but at the same time they add to be 11. Okay. So 6 and 5. It doesn't matter the order in which you put them. Whoops, what happened there? That's not what I wanted to do. Excuse my 6 and 5. Okay. And we go to the next problem. They're asking us to factor that. Okay. As we wrote, it's got to multiply to be 48, and it's got to add to be 14. And here are those numbers down there below. And first again, we always think of 48. And we lay them all out, not just the first 2 we think of, right? And when we lay them all out, we see that these 2 here, if I added the 6 and the 8, they would give me the 14. So therefore, it doesn't matter which way you put them. If you want to put the 8 first and the 6 second, that's fine. So you could see that if we understand the pattern on how to double distribute, we can undo it and factor just as easy. So let's try some together. Okay. So we have x squared plus 10x plus 21. I'm going to start doing this a little bit more of a shortcut. It's got to multiply to be 21 and add to be 10. Okay, so we've got to think of numbers that multiply to be 21. Well, there aren't too many, are there? 1 times 21. And what else? Well, 7 times 3. And that's it. Which ones produce a 10? Right there. So when it's time to factor, we produce parentheses. We also see that x squared, that's kind of like a no-brainer step. In order to get x squared, I need to always have x and x. Look, even the next one, I might as well lay out the x and the x. And for the x squared, I might as well put the x and x. And it's got to multiply. Let's come back up to a. It's got to multiply to be 21. We said the numbers are 7 and 3. And we're adding to be 10 and multiplying to be positive 21. That's plus signs all over the place. Here we've got to multiply to be 8. That's 1 times 8 and 2 times 4. And we could see in order to make the 6, it's 2 and 4. Done. And here we've got 18. So we got 1 times 18, 2 times 9, 3 times 6, and we're all done. The 3 and 6 doesn't work. That gives me a 9. I need the 2 and the 11, the 2 and the 9 to give me the 11 I'm going for. Okay. And quickly, we'll come and do these. And the nice part of these all have plus signs all over the place. So when you're factoring something with plus signs, we know inside the parenthesis are going to be plus signs. We also have that easy step that says, hey, in order to get x squared, I got to have x's. So we're thinking of numbers that multiply to be 28, add to be 11, 7 and 4. We're thinking of numbers that multiply to be 30 and add to be 13. 10 times 3 is 30, and it's the one that adds to be 13. And again, I can tell right away I got plus signs everywhere, so I'm going to put plus signs everywhere in the answer. It's got to multiply to be 14. That's either 1 times 14 and 2 times 7, and it's the 2 and 7 that adds to be the 9. Okay? Nice when everything's positive. Now let's throw in some negatives. So now keep in mind, it's got to multiply, and let's think about that sign. It's got to multiply to be negative. The only way that works is one's got to be negative and one has to be positive when we're multiplying. So you might as well drop in those signs right there. And now lay out 15, which is 1 times 15 and 3 times 5. Which one will produce 2? Well, 5 and 3. If I subtract them, because one is positive and one is negative, that's like subtracting them, I'll get 2. However, I want it to add to be negative 2. For the negative to dominate in the final answer, the big number has to have the negative. So the 5 gets the negative sign, and the 3 gets the positive sign. If you had them mixed up, you'd see that these add to be positive 2, and we needed them to add to be negative 2. Okay, it's got to multiply to be 40, and it's got to add to be 3. So to the right, we took all the numbers that multiply to be 40. It's 5 and 8. So we got to remember that one's positive, one's negative. It doesn't matter which one we stick where, okay? I could put the negative first. I could be in the mood for putting the positive one first and the negative one. But in the end, it's got to add to be positive 3. And that means the big number 8 gets the plus sign. So as I put them in there, the 8 gets the plus sign. The next one, it's got to multiply. That's what the green writing's for. Multiply to be 32. I don't have to put the little m up here and add to be. Now careful, it's got to multiply to be positive. Oh, but is there plus signs all over the place? Like the top of the page had plus signs all over the place? No. So it's got to multiply to be positive. That means it's either 2 plus signs that multiply to be positive or 2 negatives that multiply to be positive. And we said that the 2 plus signs occur way at the top of the page when everything's positive. So that means I'm going to have 2 negatives that multiply to be a positive. And they got to multiply to be 32. And I can start with way over here, 1 times 32, and 2 times 16, and 4 times 8. And there's the one that makes the 12 for me. And it doesn't matter which one goes where, 4 and 8. Notice they add together to be negative 12, and they multiply together, a negative 4 and a negative 8. Multiply to be positive 32. Let's go to the next page. Okay, here's a mixture of some problems. I would hope that you would pause the video and try them on your own. So I'm going to give you a minute to do that, and then I'll put the answers in. So I put the answers for the first couple. Remember, it's got to multiply to be 12 and add to be 4. 6 and 2 is the right combination, but I got to watch my sign because it's got to be a negative 4 when it adds. So the negative has to dominate in that subtraction. So the negative goes with the big number 6, and the positive number goes with the small number 2. Same thing for the next one. It's got to multiply to be 24. Oh, but watch now. Wait a minute. It's multiplying to be positive. 2 pluses or 2 minuses? Well, it can't be 2 pluses because there's not pluses all over the place in the question. It's got 2 minuses. So that tells us that both signs need to be negative. 6 and 4, both negative. Add to be negative 10, multiply to be plus 24. On the other two, plop down the x. It's got to multiply to be negative. So let's put down the signs. One has to be plus. One has to be minus. Now we'll worry about the numbers. I got 1 times 18, 2 times 9, and 6 times 3. I need to make a positive 3, one being positive and one being negative. It's going to be 6 and 3. I got to put the 6 where the positive sign is going to dominate and 3 where the smaller number is. Once again, as we go to the last one, it's got to multiply to be positive, but it's adding to be negative. So before I even get started thinking about the numbers, I got the signs down. X minus, X minus. So it's got to multiply to be 24 and add to be 11. 8 and 3. Hopefully you did well. Now, very important idea to factor. When we were together in the last time at the video, we decided to always think about the GCF. Now look at this term. If I asked you to factor that, this term does not have a 1. It has a 3. And that could be a hint that maybe a 3 needs to factor out of 3, 30, and 72. And when you do that, when you pull that GCF out, look what's left. X squared plus 10x plus 24. And you might think it's all done. So the first thing you do, though, is now that you created the leftovers that we put in the new parenthesis, we look at those leftovers and say, wait a minute, that's an x squared term. We just did a page and a half of these type of questions. So remember to bring down the 3. And this is going to be factored one more time. And the nice part is we got plus signs all over the place. And with plus signs all over the place, we know we're going to have x plus. It has to multiply to be 24. 6 and 4. Okay. And that one is completely factored. Now don't forget the 3. That's also part of the factored form. So I'm going to get that out of there and make it look nice and pretty. I'm going to put it in blue so that we have everything consistent. So see that 3, put it right next to the other 2 factors, x plus 6 and x plus 4. Look at the next one. Doesn't have an a of 1. So we're going to try and factor out that 2. And when we do that, it does come out of all those even numbers. I get x squared plus 7x plus 12. And now I'm not done. Now that new parenthesis, I look at it and say, it's an x squared. It's got 3 terms. I got to give it a shot. I'm going to put my x and x. I see plus signs all over the place. It means I'm going to be plus and plus. It's got to multiply to be 12 and add to be 7. That's a 4 and a 3. And as we look at the next one, we're going to see a little bit of a difference. First of all, the a is not equal to 1, but it is not a 3-termed expression like every problem we've done on this page. It's only 2. So all you're going to do is factor that GCF, because we see a 5 is also built into that 20. So I'm going to pull a 5 out, and I got an x I could pull out. When I do that, what do I have left in the first term? Well, I pulled the 5 and an x out. That leaves me 1 more x. And what did I pull out when I had 20? That leaves me a 4. And that is it. Look in your new parenthesis. That doesn't go again. So sometimes you can only take out the GCF and be done, which again is what we had in our first problem. Our first video was all GCF. So you could see you could take the new material on factoring trinomials, 3 terms, and if the a is equal to 1, we go right to the double parentheses. But right now, if the a is not equal to 1, like on these last 2 problems, we try and factor out the 3 and the 2. 3 for the first problem, 2 for the second problem, and then look at the new parenthesis and realize that, that might go one more time. As we look at the last page, one question: is it possible that a quadratic trinomial cannot be factored? So let's say I asked you to factor that. Okay? And the answer is already there. Okay? We already gave you the answer. No, it's not factorable. But we would try it. We'd see we got plus signs all over the place. And we got x squared, so that puts an x plus. And now I got to get the numbers that multiply to be 18. There's the 3 combinations. None of those make a 5. Therefore, we have to go through the work and give it a try. But it does not factor. And we say that an expression that doesn't factor is considered to be prime. And once in a while, you may come up with an expression that's prime. Here are some questions. They're not on your worksheet. They're not in the notes. They're only on this video. You should stop the video. Try all these problems. And only then you can move to the next page, which has all the answers. So make believe you paused the video, filled in your answers, and now you're going to go check them. And don't look at this last page of the video until you did the previous page. Okay, So there's 2 videos that I'm going to attach in an email about factoring. And we'll be talking about factoring a couple other methods. These are the first 2. Okay, talk to you later.